I came to Caltech in 1964. I came as a postdoc and then became a faculty member in 1967, setting up a research group in space physics with Robbie Vogt. Then that was in 1972 when I was asked to spend part of my time at JPL as the chief scientist for this new mission, which was called at that time MJS-77, but which became Voyager.
We have liftoff of the Titan Centaur, carrying the first of two Voyager spacecraft to extend man's senses farther into the solar system than ever before.
I hesitated because I was a fairly young professor at that point, still had a lot of research I wanted to do. We had some discussions about how to focus on the science leadership, and I felt I could continue my research here on campus, working with students and building instruments, and some graduate students actually worked on Voyager with me. Our first encounters with Jupiter were in 1979. The next encounter was the Voyager 1 encounter with Saturn in November of 1980, followed in August of 1981 by Voyager 2. After the Saturn flyby, we had a nice cruising period until 1986 for Uranus, and so I did, in fact, teach Physics 1 again. The wonderful thing about planetary flybys is there's a lot of freshman physics that you can talk about. The encounters, the trajectories, what we see is often has some very basic physics principles you can talk about. So I found a wonderful way to include in the regular classical physics that you get in Physics 1 some relevant things that are happening now. Caltech is really a unique place. It has the community that you expect from a small college, but it's doing really major world-class research. Caltech founded JPL, and then when NASA was formed in 1958, it became owned by NASA now and run by Caltech. And so that makes it possible for a professor here to actually go to JPL on a part-time basis for an extended period of time because it's all the same university.
The event in the mission which really altered our view and our expectation for the rest of the mission was the discovery of the volcanoes on Io.
When we saw Io, we had never seen anything like it because it had these large features. There was this heart-shaped pattern, all these black spots. We had no idea what we're looking at, even though we had had all these hints. As we got to closest approach, the infrared PI, Rudy Honnold, came in and said, you know, there's some peculiar spectrum here on the Io. One possibility is we have a calibration problem. Maybe it's a new kind of material which has this particular temperature profile. And another was maybe there's more than one temperature on Io. And we all sat there and listened to this, and not one of us said, that explains what we're seeing. And when I went to optical navigation, here was this white appendage on Io. Occasionally I'll have little sketches here and there. But here it is, there's Io. And see that little thing I drew there? This was the sunset line. And that's, you could see this bright thing up above the dark surface. And she'd done a lot of work with Linda Barbato and was convinced it was not just another satellite that happened to get in the same field of view. And a couple of days later, Rudy Honnold came in and said, we have hotspots, which are lava lakes. It was just a remarkable story how hard it was for us to take the leap that there could be a small moon with 10 times more volcanic activity than Earth. And that really opened up our eyes that we were in for a mission that was going to really stretch us in terms of our understanding of planets and understanding of Earth. I think we just time after time found that nature was much more inventive than our models. Usually it's the things that we don't anticipate which turn out to be the most important, just that we didn't know that they were out there, whatever they were.